Hello, everyone. Thank you for joining me for, I hope, exciting presentation on uphill battle of mobile visual regression. And so, first, we actually need to determine whether it worth your time to stay here. And we're going to talk about what goals we set for this presentation. First goal is pretty obvious and simple, is to actually talk about visual testing in a short note. So basically what, why, how, and when to use it. The second is more interesting goal is to actually look at with a new perspective on a well-known test pyramid that we all use and love. And the third, more practical, it's actually for you to take away some of the tools that I'll mention here or inspire you to build your own. So the title of this talk actually mentions mobile, but mobile can be presented in different shapes and platforms. And so with that, I actually would like to be more clear what exactly we're going to talk about apart from native mobile. So obviously native is going to be mentioned here. It's going to be iOS and Android for some of the examples I'll talk about. But at the same time, we're going to touch on responsive applications, which basically are web apps that correspond to the change of width of your browser by changing the page layout and possibly content on the page. And last but not least are hybrid apps, which are picking up in popularity. In particular, we will focus on using React Native in this example. So I have a question for you guys. Do you actually write automation, or are you mostly doing manual testing? Great, great. I mean, I think I made a mistake asking 2 questions. I should have asked 1. But I'm pretty sure it's mostly automation for you guys. And it's actually good because I'd like to ask you, how do you actually test? What primary concept leads your way of testing systems? And before I actually ask this question, I'd like to give you a hint. It has something to do with geometry and some sort of shape that we all know. Kind of mentioned at the beginning of the presentation. Give you a second hint. It has something to do with Egypt. Test pyramid. I'm not going to keep you in the mystery here, but again, we all know what this test pyramid actually means. Every layer, you can see by the width, is going more steep to the top of the pyramid. So as you see, unit test takes most of the space in the pyramid. It means you should have majority of tests. It might be testing just a single function, just single behavior. It's obviously the lowest cost for developing and maintaining this test, highest speed, meaning feedback coming really quickly, and it's lowest fidelity, meaning that the confidence in your overall system is the lowest on this level. So to tackle this low fidelity issue is to actually go up the level to integration tests, which is basically a combination of units. And last but not least are end-to-end tests, which commonly called UI tests, which are obviously more costly in developing, maintaining, and actually running them. Speed is unfortunately a factor here, but fidelity is usually high, which means people usually rely on them as a sanity tests, to verify, is my application still working after a change? So that's pretty simple, test pyramid. But now let's actually apply it somewhere. And as a speaker, I'm actually getting thirsty when I talk, and it actually will make sense in a minute. So first thing I think of is a drinking glass when I'm thirsty. So what do I do with a drinking glass? I actually pour water in it. And what do I get? It's a glass with water. What do I do next? I drink it. And I end up with an empty glass again. So it's kind of trivial, simple, and you're probably asking yourself, why am I talking about that? It's because the glass at the beginning is actually a unit. You can apply unit testing here. You check, is the glass fits in my hand? Is it made of glass? The second is integration. You integrate water and the glass together, and you're making sure it works. And the third is end-to-end. My main goal, the scenario here was for me to drink water, and I was able to do it all the way from drinking glass, pouring water in, and drinking it. So it's not just a drinking glass here. It's a test pyramid and a drinking glass together. Again, we're probably done here, right? Not really. Otherwise, the talk wouldn't be called visual testing. So unfortunately, I dropped my glass while I was drinking, and so I get a crack on it. Now, I'm still thirsty, so I pour some water in, and I get water in, though, but a lot less than before. So I still try to drink on my own risk, and I'm able to drink water. And again, it's a unit integration and end-to-end. So functionally, my goal to drink water was achieved, and I still have a test pyramid applied here. But at the same time, you might be asking yourself, is anything missing? You probably noticed that in these two glasses, the amount of water is different. And visually, these two glasses are different. At the same time, the same function of me feeling thirsty, drinking this water was achieved. So functionally, they are both the same. But there is a difference. There is a visual difference that you can see here as a crack on the right side. But at the same time, you can think of this water as a user experience. If your application has a visual regression, you might end up going from the full glass to just a partially filled glass with just a little bit of user experience. And more importantly, this visual regression might show that the entire integrity of your application is at risk. Because in this case, my glass can break completely. So the answer to this is to actually apply visual testing. And the visual testing in just the 4 main points is the test of visual content itself, visual animation, dynamic content, which I'm going to talk about a bit more details going forward, the page layout itself, which basically results in the testing responsive design. And here I'd like to make a statement. Functional manual testing is difficult. It's tedious, it's repetitive, but visual manual testing, I will say, it's nearly impossible. And the reason why I can actually say that is because I'm backed by science. I'd like to actually show you just a couple of points. You don't have to read it, and I don't think you actually can, quite far. The whole point here is to highlight that the topic of visual testing has been studied for years now. The overall studies show that humans cannot distinguish differences between two similar images that changed slightly. Like the exercise that you've done when you were a kid, find 10 differences on 2 pictures, is actually quite challenging. And it was shown it's nearly impossible for humans to do it properly, especially on the scale. So what is the conclusion here? Visual testing needs automation. But obviously, where does it fit on the test pyramid? That's an important question to ask. And I say it's on every level. So let's look back at our test pyramid that we had before. And I'd like to introduce you to visual test pyramid. So it's similar shape. But here I actually would like for you to think of it not as a pyramid, but as a mountain, as a hill that we're trying to conquer. Again, this talk called uphill battle, and there is a reason for that. And so we're trying to climb this mountain throughout this presentation. So we'll start by talking the CSS and DOM test, the lowest unit testing. Then we'll go towards visual component tests while respecting and understanding the same concept of low fidelity, high speed, and the low cost for these types of tests. And we will end up with page tests, which, again, meet the same criteria as the regular test pyramid. And we'll try to approach each of these levels from the perspective of mobile that I mentioned, whether it's responsive, hybrid, or native application. So with that, actually, I'd like us to go on this journey together and start climbing the mountain. And so first, obviously, comes the CSS and DOM testing, the lowest level, the unit testing. And here, actually, for this presentation, I built 4 different variations of the same application using as a responsive app using React, the hybrid app using React Native, Android with Java, and iOS with Swift. For this first level of unit testing, focusing on DOM and CSS, we're only going to talk about responsive and hybrid apps. So with that, actually, I'd like to try to do a demo. So with the snapshot testing, well, basically, first I'd like to introduce you to this very Canadian, I hope, kind of application, trying to be very polite here. So I say, hello, America. And if I go back to Canada, so they take me back, I can say, hello, Canada. Very simple application. You can build it easily on React or React Native. But at least it has a single functionality that changes the views and the states of these components by just click of a button. So the application itself doesn't really matter to us. What matters is for us to use a tool called Jest, developed by Facebook, and it's open source. And so what it allows us to do is, with applications like the one I just showed you using React, which is built as a responsive app, it uses so-called virtual DOM. So that snapshot testing implies to generate this DOM ahead of time, along with CSS, save it, and then as you run your automation, you compare a new DOM and CSS to the one you saved. So it's similar to screenshots, but it's lower level. again, we respect the idea of low cost, high speed, and low fidelity. And so how to actually use it? Again, I'll share all the code afterwards. But basically, it's very simple to install. I already did that. You add in your script test to point to jest, and you simply run it. And so to actually show what I've written here is, I have a simple component which I called change country, which nothing more than the button that you've seen in the previous site of the browser. And so you have a style here. You have the component itself, which basically generates some sort of a DOM here, basically regular button with the label, style, and the class. This is fairly simple, but then you write the test. So the test is simple. You initialize the test itself, you name it as you would, then you render the component itself, and you go and you format it, and you actually do the assertions. If it's the first time you run this test, it will create the snapshot for you. The second run, it will try to compare. Let's actually run it. So the run, again, will be fairly quick because, again, this is a unit test level. As you see, I didn't have any snapshots. It shows that it all passed, obviously. And let's actually look at how it appears. So again, it's a button, class name, CSS, everything is here. Now, let's actually make a quick change to our component. Let's make a space, and let's change the font size. And let's rerun our test. So developer made a change, and now in our test, it's very well shown here, even in the terminal itself, that we have a difference in the font size and in the label itself. So with this simple unit test, you're able to have your responsive app and test it on a very low level. So with that, going forward, we think, is it enough? And I say no. And I'll actually show you why. Again, the responsive app and why mobile is important here in this presentation is because as you go to changing the states of your app, so as you started with the desktop and you're trying to make it responsive, going down. So again, as you approach, if you look in an iPad, it looks fairly well. But as you go down to the, you're approaching mobile, it seems to be shrinking. Then, when the state changes, something happens. And 374 is basically the format for our phone. But if right in between of the states, you might see that, oh, the flag disappeared, but it still occupies the space, which means that CSS is not enough for us to validate the state of our application. So this transition states shows us that we actually need some sort of testing on top of the CSS and DOM. And what is the solution? Is to go up the level to visual component testing. But let's take a step back. I'd like to actually consider this application. Let's say it's written in Android, and it's actually written in Android. The top level is actually a component using text. It uses a component text view. You don't build your own component for Hello America view. You're using the existing text view, and you just send it the label. The second component is an image view, and it just consumes the source to the flag. And third is just a button. So in a combination, it actually creates your application. So this is what component-driven development is. And this is what we're going to focus throughout majority of this presentation. So a quick glance at storybooks. Storybook is amazing. I think it's actually great. A way to document your components, whether it's React Native or React. And it actually, basically, you have a component, that's the data range picker. This is, by the way, Airbnb. They have a great example of Storybook. And you can see different states right out of the box that they defined, which acts as a documentation and as a way to test it, which I'll just talk about in a minute. So this is what Storybook is about. Again, I won't be covering it in too much detail. What I'm going to focus on right now is more of a mobile and responsive app. So again, our testing demos, we're actually going to cover all four platforms here. Screenshot testing. As we've shown in the previous slides, screenshots are important. Just relying on DOM and CSS is not enough. So all the screenshot testing have three main pieces: the view loader, action driver, and comparison driver. View loader allows us to render the component and take a screenshot of it. The action driver triggers the click, send text events, and comparison compares snapshots that have been taken. So let's look at one example of Phantom CSS, a well-known tool which was actually recently deprecated. It's view loader, it's Phantom.js, headless browser. Casper.js that triggers the actions like click, mouse or send the keyboard characters. And the resemble.js compares the screenshots. And so let's actually demo that really quickly, and because you will be able to reuse it for any other tool that you might be developing yourself. The thing is, I mentioned Phantom CSS was just deprecated at the end of last year. And the reason for that they stated is because with headless Chrome and other solutions coming out, it's very apparent that anyone can develop their own solution in-house. And so let me show how Phantom CSS is structured, and you should be able to reuse it and build your own if you'd like. So for that, again, installing Phantom CSS, very straightforward, a single command. You're updating your test script. I was very targeted to specific files, so I don't have to pass an argument. And you just run it. So a test, again, is fairly straightforward. What it does is you initialize the Phantom CSS. You point it to the URL that you'd like. In this case, I built a small application called Calculator in just HTML5. You specify resolution, and you write the test itself, which is straightforward. You focus on the component, which is the body itself. You name in the screenshot, and you take in it. And then it compares screenshots, basically does the assertion. And at the end of the test, it closes it. Again, these instructions are mostly to show you the concept, not to show how to do it exactly, but the code will be shared with you afterwards. So let's actually quickly run it. So what it does first time, it obviously tells you, is it the first time running this? And you say, of course. And what it does, it creates screenshots for you, which is very nice. So let's look at the screenshot. Too big. Yes. So again, it's a simple HTML calculator, so you won't actually see much here. But let's make a change in our HTML. Let's make a change, and let's say delete the last row, and rerun the test, and see how it actually behaves and what it tells us. So what's important here, it says, oh, something went wrong, and your application changed, and there is a mismatch percentage, the threshold of a difference that you now have. And to actually see it, you will see this weird color, purple, which you can actually change if you'd like. But this is pretty significant, right? You won't be deleting the entire row. And so instead of doing that, let's do another test really quickly. And what's it called? Rearranged. Let's rerun it again. So in this scenario, we actually have the same number of columns, but they're misaligned because the characters are different. So instead of 0, you have 7. Instead of equal, you have minus, etc. So this is how the visual testing itself looks like, the comparison of images. And the whole thing about Phantom CSS and what they encourage you to do is to build your own tool like this. And a good example currently is Backstop.js. It's an amazing tool, very easy to start with, configuration-driven. And what it does, again, the view loader is a puppeteer. Chromie.js you can use to drive actions. And the Backstop.js itself performs the comparison. But actually now let's look at a native screenshot testing. And with that, obviously it follows the same pattern, view loader, action driver, comparison. So for Android, nice tool that we have is called Screenshot Tests for Android. Very descriptive. And there is another one called on iOS Snapshot Test Case. These, I would admit that these frameworks are well named. The first one is released and maintained by Facebook. iOS was released by Facebook, but currently maintained by Uber. We're going to demo Android. So let's actually look at how Android does it. So let's go to our Android Studio. So what you do here is you use your Gradle to add dependencies to this framework I just mentioned, and then you write your instrumentation test. And so let's actually look at this. So again, you built your own test, annotated with test. First, you establish the context, as you would with instrumentation test. Nothing special here. You create the view. You focus on a particular piece of your application. To actually show you the application, this is it. I mean, it's very similar to the one we saw in the React. But it's basically fragments with a flag, label, and you can switch between countries. So going back, let's say we have a test for the entire fragment itself, Hello America. We create the view, establish the width, and then we just take a screenshot. So with just these few lines, you're able to generate snapshots and then compare them. You can be more precise. Again, just set up the context, focus just on a flag, same way you would if you were to write, let's say, a WebDriver test. Sorry, it's just the way you would retrieve view using Android itself. And you take a screenshot the same way you would. I'm not going to run it right now. It's simple command and Gradle, but this is what it actually produces you. It's fairly fast, but first time installation takes a while. So this is basically focused on the flag itself, and this is how it would look for the entire fragment. So it gives you quite a bit of information, but it's basically as simple as it gets. iOS is very similar in that regard. So Enterprise obviously jumped on this solution. So we have a screener.io that does quite nice integration with Storybook to actually take screenshots of those components I showed in isolation. There is a flawless app.io. It's a startup in Europe that focuses on iOS visual testing. Chromatic is the tool that I don't believe they released to public yet, but it's also focused on the Storybook testing. And last but not least is Percy.io. It's fairly nice visual test that integrated with has a continuous integration, and recently they released integration with Storybooks as well. So, best practices. Screenshot names. Obviously, with software itself, naming is one of the biggest challenges, so you have to take care of your snapshots from the start. The Git media is a nice extension for storing these snapshots. The problem is snapshots can get out of hand really quickly. They can be too large, and submitting them along with your primary code can be challenging and quite heavy. So Git media, what it does, it abstracts those commits to commit to S3, for example, to Amazon or Azure, or whatever you'd like, while still maintaining the same flow of Git. Component testing first. Always focus on components first. Don't go to the page snapshots and the screenshots right away, because big problem with visual testing itself, whether it's native or hybrid apps or responsive apps, is the things like dynamic content or animation. And to actually tackle those, you can change the threshold of a failure that you accept, basically the difference percentage which I showed a couple slides before. You can use a framework called faker.js, which basically replaces dynamic data with static data. And there are other solutions that you can try to implement. I'll talk about Applitools in a second. They actually tackle this problem quite nicely. And of course, try to use the test pyramid itself to apply its practices to visual test pyramid itself. So the conclusion, DOM and CSS is not enough. Development and testing, the line between them really blurs, because as you build the component, they also act as a documentation and ultimately as testing. You can choose your own solution, or you can build in-house. That's what Phantom CSS tells us, and what actually people do. If you were to explore the visual testing a bit more, you would see there are so many tools out there. And so with that, we actually will move on to the last part of this presentation and try to actually climb to the top. It's the page testing. So responsive testing here is what's important is window size, particularly width of a window that you view your application in the browser. Transition states that I highlighted a few slides ago is what's also important to focus on. You can just focus on DOM and CSS. If you're using Selenium, and Selenium is commonly used for responsive applications, you can just set the window dimensions and simply retrieve CSS properties from the elements. You can go that far. Or you can use screenshots along with your Selenium using Applitools API, for example. What I actually would like to demo is a bit of a native visual testing with Appium and Applitools. So let's go to the last demo of today. Here it is. So, okay, so first of all, obviously, in the setup itself, you initialize the, actually, let me expand it a bit. Yeah, so nothing pretty here. You initialize your Appium driver, you point it to your APK, your Android application, you initialize ICE, which is the API from Applitools. You set its API key, and you open them up. You open the ICE up. And then you give the test itself a name. Again, naming is extremely important. I believe we all agree. The capabilities, you don't have to actually look at them as much. Right now, they pointed to Android, and this is what we're going to test it on. More importantly is obviously the test itself. This is a simple test for the entire application. So in this case, we just open a window, and we name it Hello America. You can even check the region if you wanted to. So let me actually run it. OK, let's run it. Run. So the thing is, I already ran it once. And now, let's see what actually produces. OK, while it's running, and it should be fairly quickly, I will open the browser already connected to my Applitools account. So it basically shows us that we already had a screenshot before it was taken. Quite nicely shown here. But now, let's actually refresh and see what's going on. Oh my God. OK. So again, it's passed again. Interesting. Why did it pass? Let me see. OK. It wasn't expected. So honestly speaking, I expected that the time would change. And let me just show it to you right away. So the whole thing, if you notice, the entire screenshot shows up here. And this is fairly bad. Why? Is because this top level, you see the time? Imagine the test runs a minute later. The screenshot would change. And you don't actually want to pay attention to that. And Applitools, why I really like them is because they provide you quite a few solutions out of the box on their dashboard. And here in this screenshot itself, without modifying my test, I can just say, you know, this top level, just ignore it. And so now if I run the test, 1 minute later, it won't actually fail for me. It will succeed. So I save it. And if I were to rerun it now, it would pass for me. So that's basically how Applitools, for example, tackles dynamic content, and which you can actually integrate with your solution. So with Applitools, you can integrate them with Appium for native or with Selenium if you wanted for responsive app testing. So enterprise obviously has solutions. Applitools, as I mentioned, one. Browser stack is similar to Sauce Labs solutions, but very popular in Asia. Sauce Labs themselves, obviously, and Test Objects, another product focused on mobile from Sauce Labs. So now we actually summit. We reached the top. And what is the question here is, what are we going to do next? So the next is obviously to think of how you're going to integrate this pyramid at your workplace or your own personal projects. And so the call for action here is for you to start the climb. Start tackling this test pyramid, and whether you're working with mobile, with just web applications, with responsive hybrid apps, doesn't matter. You can start by just doing the unit testing, going to the component tests, or all the way to page tests, maybe for sanity. So that's basically one of the main goals and takeaways from this talk. And I hope that when you go to work tomorrow or on Monday, you'll be able to at least look at how you can enhance your product today. So with that, I'll move on to the Q&A. Yes. Oh. You could tell me, I will just repeat. So I'm mobile application and from your mobile visual testing.
From your examples for mobile visual testing, I see that you mostly use emulators, right? So you cannot apply it and test on real mobile devices. For example, screenshots, they are different from the device to device, especially in Android. Am I correct? So your testing, you perform on emulators, right?
So with actual devices, not emulators, this is where solutions like Browser Stack or Sauce Lab come in. And the solutions they provide, they allow you to run this test that you write with Applitools, with the Appium on these real devices instead of just emulators. And that's why people actually use the Browser Stack or Sauce Lab itself.
But the visual testing specific. So.
Yeah, the whole thing of one of the points of visual testing is the screenshots, right? And so if you load it on the, oh, sorry, I forgot to repeat the question itself. So yeah, the question here was that how do you run it on the, how do you do visual testing on actual devices? So again, you write the same code which takes screenshots currently on my local from the emulator. If you run it on the actual device, it will take a screenshot on your actual device.
If I have a bunch of them.
Yeah. If you have a bunch, that's the thing. It scales them and saves them in the, it depends on what solution you use, but ultimately it's the same flow, whether you take a screenshot from emulator or the actual device. So, yes, please. Oh, sorry, it was, oh yeah, I'll let you to lead it.
Hi, thank you. You're talking about building your own, kind of rolling your own, but then talking about Applitools. In your experience, is the ability to ignore certain areas of the screen that's offered by Applitools, is that unique?
It depends. It depends what you'd like and how much time you can invest. Like as any engineer, we really like to jump in and reinvent the wheel. So you should be cautious of that. So while Phantom CSS or your inner calling encourages you to implement your own solution, your product owner and your company might not agree. So you use the applications such as Applitools. So if you were to use, for example, Backstop.js or Phantom CSS, instead of selecting area to ignore, you can just focus on the certain selector, certain component right there in the code. Here you're just taking kind of step, abstract it a little bit. From here you can actually select it in the UI rather than writing it in code. So all solutions I've shown so far, Phantom CSS, Backstop.js, and even snapshots on Android, you can select certain components. And Applitools, you can do this selection on the UI itself as well. So it's not unique. It's a good question, though. Good question. Oh, right here.
In your example, the screenshots that you are comparing with, how do you do that for different form factors? So you need to store the screenshots of application in different devices and different browsers when you are running the test?
So, for example, with the Backstop.js in the configuration, you can only specify primarily the resolution. So, but you give it a label, so it will store the screenshot of resolution that you specified with identifier. Let's say you called it, iPad 1, iPad 2, iPad 3. So you can change the factor of loading the browser. But if you were to, so I'm not sure if I'm answering your question correctly, if I understood it right.
Different browsers have different screen sizes.
Oh, that's what you meant. Oh, obviously. So if you use Selenium for Selenium, you can change different drivers, right? You can run it against Firefox, Opera, IE, whatever you choose to. But the logic will be the same. If you're using Applitools under the hood, it's totally fine. If you're changing the width directly on the driver, driver.getWindow.set dimension, doesn't matter. This just enhances your current solution. That's the whole thing of visual testing. It's what the appeal is. If you have already tested Appium or Selenium, you just add Applitools, or you just enhance your current solution. So the same way you would do it with Selenium.
All right, I think we're out of time.
Oh, sorry. Yeah, we could chat right after if you have any questions, but thank you so much for listening to me.